Categories of shock. So Nunez, how many categories of shock per the slide? 4. So you need to know that. All right? So, again, I know I have it up here, but when I call on you, just shoot from the hip. Okay, don't read the slide to me. Madison, what is cardiogenic shock? What's going on with cardiogenic shock? What's the pathophysiology behind it? Just think of the word, cardiogenic. What is the problem? The heart. Now what's going on with the heart?
It's not working right.
There you go. Heart is not working right. That's cardiogenic shock. Because when the heart's not working right, blood's not being distributed out to the body. What's in blood that the body needs? Okay? And that blood needs to get to those areas so that way the CO2 can be eliminated. But if blood's not getting there, CO2 is not being eliminated. That's the problem with cardiogenic shock. What are the types? Congestive heart failure. That's where the ventricles are basically sick. And acute myocardial infarction, that's where the heart muscle is beginning to die. Both of those would cause the heart to not work right, correct? That's cardiogenic shock. All right. Stevie, what's obstructive shock?
Obstructive?
Think of the word obstructive.
Something is obstructing something.
Okay, you're right, but what is the something that's being obstructed?
Trying to
Think about your perfusion triangle. There's only 3 possible answers. Which one could get blocked? The heart. Okay? The heart's working, but as it's pumping out that blood, something's blocking it. And something's obstructing it. Okay? So, this is really not an issue, like with cardiogenic shock, the pump is a problem, right? With obstructive shock, it's really nothing to do, so to speak, with the perfusion triangle. And the reason why is because cardiac tamponade. Is that the heart's fault?
Nope.
Something happened to where that fluid is building up around that sac, right? So that fluid building up around the heart is obstructing it from fully compressing and fully resting. See how that works? Pneumothorax, is that the heart's fault? But that air building up in the chest cavity is just like the tamponade. It's squishing the heart. It's blocking it from working hard, and it's blocking it from resting. Okay? I said usually the problem is not with the perfusion triangle. Well, pulmonary embolism is part of the perfusion triangle, right? Because that's your pulmonary arteries. What's going on there? There's a block there. There's an embolism. It could be a blood clot, could be an air bubble, or it could be a foreign material. Traveled through the body, came back to the heart on the right side of the heart, pumped out to the right side into the lungs. Those vessels get smaller and smaller and smaller, right? Till it lodges somewhere. And when it lodges somewhere, blood flow is not going to that lung area to get oxygenated, which means the body is not being properly oxygenated. Okay? So that's obstructive. Okay? Mariah, what is distributive shock?
It causes vasodilation.
There you go. So the problem is, we're back to the perfusion triangle being a problem, right? In this case, what's the problem?
Vasodilation.
Which is the
The vessels.
vessels. The vessels, what? Vasodilation, all right? But what's causing it? There are 4 causes of vasodilation. 1, anaphylaxis, okay? You guys learned through that chapter that when the body receives an antigen in it and it doesn't like it, it's going to try to reduce it from being spread throughout the body. How does it do that? By causing vasodilation. So the blood doesn't move like it's supposed to. So that antigen doesn't travel throughout the body. Well, that's a bad thing, right? Because if that antigen's in the blood, oxygen's in the blood, blood's not being delivered. Yeah, the antigen's not being delivered either, right? But that oxygen's not being delivered, so that's a bad thing. So vasodilation caused by the histamine 1 receptor. Okay? Septic shock. What's the problem here? Infection. Basically, the body gets sick with some foreign pathogen. Infection usually makes us sick. Like when any of us had an infection, do we feel a lot of energy? We feel like weak, right? We don't want to do anything. We just want to rest and relax. So it's basically going on with the vessel. It's sick, it doesn't want to work, it can't work because it's sick, so naturally it just dilates. So that's what's going on with septic shock. Neurogenic shock. What's that?
The spinal cord was injured.
What's that?
The spinal cord was injured.
Yep, to the point to where signals are no longer being sent to a certain part of the body. Well, when signals are not being sent, the vessels are part of that, so they're not going to get their response. And should we vasoconstrict? Tight? Not so tight, or should we vasodilate? They're not getting that signal anymore. So when they're not getting that signal, what are they going to naturally do? It's Miller time, right? It's just rest and relax, and it opens up. It dilates. Okay? Psychogenic shock. Some of you probably experienced this after you take the final on Friday. You get your result, right? Right? Your body gets overstimulated from something that hits you. Well, when that happens, when that overstimulation happens, if your body doesn't have time to react to it, it's just naturally going to vasodilate. Why? To knock you out. So nothing else is working. Because when you get overstimulated, your brain's working faster, your heart's going to want to work faster, okay? Your hormones are going to want to get released and stuff like that. But your body's doing it in a way that's so fast that you can't adapt to it. So what does it do? It vasodilates you, knocks you out, and while you're out, now it can have time to adjust to this overstimulation, which means eventually you're going to wake up. Okay? The problem with psychogenic shock is what happened when you fell, if you did fall. Okay? That's where the injury is. All right. And the last one, I'll do that one, hypovolemic. Okay? This is kind of a vessel/fluid problem. People will say it's more of a fluid problem. Yes, it's true. But with the hemorrhagic shock where there's a bleed, there's a hole in the vessel. So blood's being eliminated there. Okay? But basically, there's a fluid problem. The container does not match the size for the fluid. And when there's less fluid for the container, there's no pressure being exerted, so systemic vascular resistance decreases, blood does not move. Okay? Bleeding, self-explanatory. Burns, when that heat's applied to the patient, the interstitial space will basically suck out all the fluid from the blood to account for that heat transfer. Because it's basically the way I always like to describe it is that the skin's been burnt, overstimulated, so it needs kind of like the water for the fire, so to speak. So it pulls out all that volume out of the bloodstream into the interstitial space to kind of try to put out the fire. And that's where we get those blisters developed, okay? Vomiting, diarrhea, self-explanatory, except it's not blood. This is your electrolytes and fluid that's supposed to be absorbed into the bloodstream and moved around to kind of help you create that plasma. It's not there anymore. So the volume is depleting per the container. All right? So, you guys see the 4 categories, right? And you guys understand the example from each. Okay. Here's another one. What is the skin telling us with shock? This goes back to pale, cool, clammy skin. Okay? When we see a patient with pale, cool, clammy skin, what is that telling us? What's going on in the body? Okay? Overall, it's telling us what? The body's in what? Shock. Okay? So, pale, cool, clammy skin is telling us that the body is trying to do what? Compensate or decompensate?
Compensate.
It's compensating for it being in shock. How does it do that? Vasoconstriction. Okay? As you can see up there, you can read this, but basically vasoconstriction, and the answer is right there in both of them. When vasoconstriction happens, since blood is red and it's being lessened, you take the red color away. So thus pale. Since blood is warm and you have vasoconstriction, you take it away, that area that was once warm is now cool. Okay? Now, all that is a sympathetic response. The pale and coolness, that's a sympathetic nervous system response, which is your adrenaline, which is your work phase, right? Okay. Well, your nervous system has two sides. It has a work side and a, what's the rest side called? Parasympathetic. So when his buddy on the sympathetic side says, man, you're working hard. Let me help you out. I'm all about rest, but let me try to help you out here. So what it's going to do is going to stimulate the muscarinic 3 receptors to cause those sweat glands to start to release fluid, to sweat. Why? Because it's trying to cool the body down while it's working. So with shock, true or false, both the sympathetic and the parasympathetic nervous system are doing something. True or false?
True.
True. Okay? A lot of people have this, and the reason why this question is so big is because a lot of students were just being taught the sympathetic nervous side. No? You need there's a parasympathetic side that's working too. Okay? So that's why the skin is clammy. Any questions? You guys remember this one? From previous tests? Does anybody need you to explain a little bit more? Alpha 1 and alpha 2 are correct on here, right? Because alpha A for arteries, what's going on? Vasoconstriction. That's what we're talking about here, right? All right. You guys good? Go ahead, answer. And if you need to take a bathroom break like me, go ahead. But not with me.